Simplicity, what it gives you is expressivity, right? So right now, every layer 2 comes with a new opcode, comes with extensions to Bitcoin script, because apparently we cannot do what we want to do on layer 1 right now. And we want to change that, right? There's a need for more functionality on layer 1. But at the same time, we all know that this is dangerous, right? We have, for instance, an alternative, which is the EVM, but it does all these things that we might not want. And it's unpredictable. It has state, it has gas, and all these things that we don't want on Bitcoin. And so simplicity massively extends layer 1 using a very small footprint, which you can verify. And we actually proved that you can compute any verification, any function that verifies data on layer 1. This is not a conjecture, this is actually a proven fact. And so simplicity is able to be as expressive as you might want. Simplicity gives you these 9 combinators, these building blocks, to compute any function that you might want. And there is a caveat to this, which is consensus limits. You imagine these combinators, they are like keywords, and you combine them to form a string, a simplicity expression. And most of these expressions are pretty large. At some point, you have a very large expression that doesn't fit into a Bitcoin block, or you don't want to put this into a Bitcoin block. And so most expressions are actually disallowed by consensus. So what do? We introduce shortcuts, which we call jets. And these shortcuts basically compress a large expression into one small shortcut, one small atom. And we say, if we see the shortcut, we actually execute a dedicated optimized C code. And we prove formally, because of simplicity's formal nature, that this optimized C code does exactly the same as this very large expression that we could not put on the blockchain, that might be too large to pay the fees for. So we have a catalog of jets, and we have the combinators, and with this we can combine them. We can express quite a lot. For most things, for let's say op CTV or any pref out, you wouldn't need a soft fork. You could just use the jets and the combinators to combine them in some form. For most of these use cases, you can just deploy this on the blockchain right now if it had simplicity. And if you want to optimize it later, you can already deploy it. You can already see how it works. You can deploy it for years. And then later, when you decide this makes sense, you can introduce a jet for this specific purpose to compress it even more. So this is what Adam meant, I think, by the last soft fork, because simplicity makes many soft forks just no longer necessary. You can skip them because you have the power of jets and combinators to do a lot within consensus.